This question is solving the product property. With logarithms, we have the product property because there's a plus sign between two logarithms of the same base. So what I'm going to do first is rewrite it as the product property. So I'm going to take log 4 of x times 3x minus 2 equals 2. And then because it's a single logarithm, we're going to rewrite it in exponential form. So we're going to start here, go across, and then come back. So I'm going to have 4 squared equals the product of x times those. I'm going to distribute, so I get 3x squared minus 2x. If you need to simplify this, it becomes 16 equals 3x squared minus 2x minus 16 minus 16. 0 equals 3x squared minus 2x minus 16. A value is not 1, so I can't just jump to what I want to do for my math. So I'm going to write down A times C, which equals 3 times negative 16, negative 48, and the factors of 48 that add up to be negative 2 happen to be 6 and 8. And since I want a negative 2, the 8's negative. So factoring, I'm going to go factor by grouping, 3x squared minus 8x plus 6x minus 16 equals 0. I purposely put 8 in front because 3 and 8 have nothing the same. You put 16 or 6 in front and you pull out a 3. In my grouping, I have x being the same, so I have 3x minus 8 plus some number times 3x minus 8. 6 divided by 3 gives me 2, and 2 times the negative 8 is negative 16. So I have x plus 2 times 3x minus 8 equals 0. So x plus 2 equals 0. 3x minus 8 equals 0. X equals negative 2 and 8 thirds. Now when you check this, just like we check the other problems, we always have to check to see if logarithms of negative numbers exist, and then also if our products are right. So I'm going to start with the 8 thirds. So check. X equals 8 thirds. So I'm going to have in the first parenthesis log 4 of 8 divided by 3 plus log 4 of 3 times 8 divided by 3 minus then 2. So simplifying this also equals 2. I have no negative value here, and when I put this in my calculator mathematically, I have no negative value. So what I get is log 4 of 8 thirds plus log 4 of 6 equals 2. And what I'm checking is, does this number times this number equal this base raised to this exponent? So mathematically what I'm doing is I'm coming back and I'm checking this setup or this setup, meaning the numbers times each other equals 4 squared, which the case is 48 divided by 3 is 16. 4 squared is 16, so that's a true statement. And then I'm going to check the x equals negative 2. So same thing, I'm going to go log 4 of negative 2 plus log 4 of 3 times negative 2 minus 2 equals 2. right off the bat, that's the log of a negative number, so that's a bad thing. But what I want to do is I still want to double check that my math is correct. So I'm going to go log 4 of negative 2 plus log 4 of negative 8 equals 2. Both those are negative numbers. However, negative 2 times negative 8, checking to see if things are correct. I'm checking to see if this times this equals this base with this exponent. So I'm checking negative 2 times negative 8. Does that equal 4 squared? And 16 does equal 16. So that's true. But once again, I have logs of negative numbers, so x cannot equal negative 2 log of negative number. You don't have to give that reasoning, but you do have to disprove it. So my only answer is x equals 8/3.